All right, so in 2.7, we're going to talk a little bit about how we're going to name our ionic and covalent compounds. All right, so what is nomenclature? Nomenclature is a collection of rules for naming things. Compounds can be identified by both their formula and their name. This is important these days, with all the typing and stuff like that. You can't really put in all those subscripts and stuff and expect that any old person off the street's going to be able to read and understand that. So we're going to have to learn how to name both ionic and molecular binary compounds composed of two elements. And we're going to talk about ionic compounds containing polyatomic ions. Okay, when we're naming ionic compounds, we want to name the cation first, followed by the name of the anion. A monoatomic cation, so we only have one atom here, is just given the name of the element. A monoatomic anion is given the name of the element with its ending replaced with the suffix "ide." A polyatomic ion is just given the name of the ion. So let's look at some examples. Here we have sodium and chlorine coming together to form a compound, and we call it sodium chloride instead of chlorine. Here we have potassium and bromine, we call it potassium bromide in this case. Similarly over here, we have calcium and we have phosphate, calcium phosphide. All right. Now, when we're doing polyatomics, all right, here we have the ammonium polyatomic, so we call this ammonium, and we still change the last part, chloride, when it comes afterwards. But up here, you'll notice that when we have the acetate polyatomic bound to potassium, we call it potassium acetate. We don't change this to acetide when the polyatomic is the anion. So most of the transition metals and some main group metals can form two or more cations with different charges. The charge of the metal ion is specified by the Roman numerals. So we need to be a little bit more specific when we're talking about the transition metals. So because iron can either be a +2 or a +3, we need to, when we're writing out the name, give it these little Roman numerals to tell us what the charge is. So we know that this iron has a +2 charge when we say iron 2 chloride, and this iron has a +3 charge when we call it iron 3 chloride. Hydrates. So a lot of times different compounds are going to have one or more water molecules associated with them. When that's not true, they're called anhydrous compounds, and we just name them like we just saw. But when it is true, we're going to add the word hydrate at the end, but we need to add the proper Greek prefix for denoting the number of water molecules. We're going to talk about what those prefixes are at the very end. But here are a couple of formulas for you here. We have copper 2 sulfate, this guy right here. We write a little dot. We see that there are 5 water molecules associated with it, so that is penta, meaning 5, hydrate. Down here, we have our calcium chloride. Get our little dot. There's 1 water molecule here. We're going to call this calcium chloride monohydrate. So molecular compounds are named using a slightly different set of rules. Basically, there are a lot of different combinations. So we're going to give pretty much all of the atoms participate, or all the names for the atoms participating in a Greek prefix. And we're typically going to start with the more metallic element, the one furthest to the left or to the bottom of the periodic table. sometimes there's a little discrepancy about which one should be the right one, and you'll actually see things written just a little bit differently on those edge cases. So try not to get too caught up on that. And then we're going to have the Greek numbers are designated for each one of the prefixes. And we're typically not going to use mono. So if there's only one thing there, we're going to skip over it. And when there's two vowels are adjacent, so like basically when the word looks a little weird because you have too many vowels running together, you're going to drop the A from the Greek prefix. The Greek prefix that we're going to use here, there for 1, there's mono, 2, di, 3, tri, 4, tetra, 5, penta, 6, hexa, 7, hepta, 8, octa, 9, nona, 10, deca. It's a little complicated to get into this video all of the different ways that we're going to name covalent compounds, but there are a lot of really great examples in the homework this week and in my homework guide that I would like for all of you guys to look at. Thank you very much for your time. You guys have a wonderful day.